Okay, I can take this because I work in the lab and we have a very good team here. Yes, we are working on other genes. I want to say that at least one other gene is working very efficiently for us. Um, Without giving too much away, we are putting together a manuscript, so I don't want to give away too much. But um, the ND1 gene is working good for us, and we are testing this again in another patient null cell line, and we have some very positive results. But again, um, most likely some of the lesser hydrophobic genes are likely to work in our strategy. And there are proteins like cytochrome B or COX-1 that are extremely hydrophobic, where when Aubrey explained that the Chlamydomonas strain, that it has transferred many of the genes that are present in the human mitochondrial DNA to the nucleus. Only 2 genes across all eukaryotes are still retained within the mitochondrial DNA. These are cytochrome B and COX-1. So most likely these 2 genes we have to do much more engineering from the efficiency perspective. But we are hoping that the rest of the genes, they'll be with them to work.
I'd like to expand on what Amantha just said, actually, because there's an important point here which leads us to even greater optimism that we are getting quite close to doing the full job. And that is that even though there are, as Amantha said, only 2 genes that are always found in any species in the mitochondrial DNA, there are more genes that are not found ever in the nuclear DNA. The reason that can be true is because those genes are in complex 1, and complex 1 has simply disappeared from some species, in particular from the 2 main species of yeast that are studied in model organisms. Now, this is really important because it tells us that actually those subunits of complex 1 that are never found in the nucleus may be as difficult to transfer as the 2 that are always found in the mitochondria, cytochrome B and COX-1. So that's quite good news, because one, as Amantha just mentioned, some of the genes that we are now having considerable success with are subunits of complex 1. Indeed, ND1 is one of those 4 that are never found in the nucleus. So actually we have a considerable basis for